Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week, and going to be examining in detail a argument that I've heard made many times by many people over the last several years, and that is that if we can't forecast the weather accurately all the time on time frames of 7 days, 30 days, 90 days, then how the heck do we expect to be able to forecast what the climate's going to do in 50 or 100 years? And that argument on the surface makes a whole lot of sense until you dig into the fact that climate and weather are two completely different animals, and that's what we're going to talk about today. So let me go on ahead and put myself down here in the corner, and we shall begin. So the best analogy I've ever heard about the difference between weather and climate is weather is your mood and climate is your personality. So your mood can change in a heartbeat, I can testify to that. But your personality is, if it's going to change, it's going to change very, very gradually over time. And so that's really a good way to look at the contrast of these two entities. Now, our normals that we talk about, the normal, high, and low, are based on a 30-year average, which is the minimal amount of time needed to see any real trends in the climate. If you go after year-to-year variations and use trends for that, it is going to throw you way off, okay? So there's a lot of noise in the day-to-day weather, but in terms of climate, that occurs over a much, much longer period of time. Here is the satellite global temperature record from the University of Alabama at Huntsville, and two gentlemen pioneered this technique, John Christie and Roy Spencer. And just to be honest, and I'm not saying anything that would make them mad or whatever, that they are in the minority of scientists that accept the fact that the climate is warming and that man has something to do with it, but they don't think the magnitude of the changes is going to be enough to cause catastrophic climate change, okay? So if there's ever a data set that you can trust would not be embellished for the purposes of promoting some agenda, this is it, okay? So you can notice an awful lot of ups and downs there, right? And these are monthly averages for the globe, and so you can see it going up and down, up and down, up and down. And the El Niños show up very, very well, the strong and the very strong El Niños. There's the 82-83, there's the 87-88. The 91-92 didn't show up quite as well, but then we had a big one in 97-98. Then we took a long break between strong and very strong El Niños, the next one not till 2015-16, and then the one we just had 2023-24. So if you connect the peaks of all these El Niños, you're going up, and that one just a temporary down, but you go up, 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 and up. So each one is getting a little warmer with time, and this only goes back to 1978. There is the long-term trend line. So again, there's a lot of noise in there, a lot of day-to-day, month-to-month, year-to-year variations, but when you take a look at the long-term average, there is no denying that the slope of that curve is positive. Now, that rate that we've seen since 1978 is 0.156 degrees C per decade, which if you convert to a 100-year time span and convert to Fahrenheit, you get about 2.8 degrees Fahrenheit for a century, for a 100-year period. Now, the thing is that we don't know whether or not this rate is going to remain constant. If we keep putting more and more carbon and methane and so forth into the atmosphere, then that rate could accelerate, okay, with time. So that's one of the uncertainties about the future. Okay, so just for fun, I picked a random date at the Raleigh-Durham Airport, and I picked March 21st, which is usually either the first day of spring or within a day of it, and just took a look at how much variance there was in the high temperature on that date going all the way back to 1945. Well, it turns out that the highest high temperature on March 21st was 89 in 1968, and the lowest one was 41 in 1986, which is a range of 48 degrees. Now, the 30-year average high temperature for March 21st has varied from 61.6 during the 30-year period 1945 to 1974 to 63.7, and that occurred during two 30-year periods, 65 to 94 and 75 to 04, and that difference was 2.1 degrees. So again, if you look at it year to year, it's very misleading, and you cannot use that to assess whether or not your climate is changing significantly. You have to look at the long-term average, and in this case, it's 2.1 degrees. So it's up, but it's not 48 degrees worth, okay? So day-to-day weather is a chaotic system. It's very sensitive to the initial conditions. We cannot observe the atmosphere perfectly. We don't have enough observations, okay? So any computer model that tries to forecast the weather for the next 7 days, there is inherent error right from the beginning. Now, it's very small, but we have found out over the years that very small changes in the beginning can make big differences down the road. And one of the analogies I used to use with school groups is that if you were in a big gymnasium and you had world's most powerful squirt gun and you were aiming it at the exit sign on the other side of the gymnasium, if you move the barrel of that squirt gun just a teeny bit either way, by the time it gets to that distance, it's going to miss that target by a wide margin, okay? So there's no question that with weather forecasting models where you're dealing with variables that are changing by a lot over relatively short time periods, any change or any error in the very beginning is going to make a big difference down the road. Okay, and climate is influenced by, I really shouldn't have said fewer drivers, but fewer drivers that are short-term, okay? These drivers change over long periods of time, and I'll actually show you a list here in a little bit. And the climate drivers I actually have as being more, but again, all of them except one operate on a very, very long time scale. And there's also been an amazing amount of warming in the Arctic, and even the most primitive climate models back in the 80s predicted that this was going to happen. And the Arctic is warming, by some people's estimate, 3 to 4 times as fast as the global average. Now, as sea ice melts, you have a relatively white surface, not pure white, but close, sort of maybe a light gray, and that reflects most of the incoming solar radiation to space. But a dark surface, which once the ice melts, it's being replaced by a dark ocean surface, is very absorbent of that incoming solar radiation. So that's one contributing factor. And then the other one is warmer temperatures mean the atmosphere can hold more water vapor. And water vapor is a greenhouse gas, okay? So it intercepts infrared radiation leaving the Earth and it sends it back down. Now, the atmosphere in the Arctic is very, very stable, okay? And what do I mean by that? Well, especially at night, you know, like at the North Pole and even close to the North Pole, it gets dark for, 24/7 for a long period of time. So the cold air collects near the ground and the temperature actually increases with height. There's an inversion. So that limits the amount of mixing vertically in the atmosphere. And so whatever warming is going on near the surface is concentrated near the surface. Whereas at the tropics, you have maybe the air mixed over 5, 6, 7,000 feet, and that warming is distributed over that entire layer, okay? So instead of it being concentrated near the ground, it's evened out or distributed through several thousand feet. And so that's another reason why the warming is going to be much more significant in the Arctic than it will be at more southern latitudes. Here is the Arctic sea ice here, and on the y-axis is the extent in millions of square kilometers. And the dotted line there is the lowest it's ever been since these records have been kept. And that was back in the year 2012. We were right on line with that for July and August. And then you can see here that we're not quite as sharp as 2012. We're not losing as much ice as quickly as we did back then. But this is the long-term average up here. And you can see that we are well below that. Okay, so things that influence weather and climate. And for weather, basic weather forecasting, you're looking at changes in pressure, in temperature, in moisture, and cloud cover. All those things are going to determine what your, and one I should have added, whether or not the air is going up or down. Rising motion leads to clouds and precipitation. Sinking motion generally dries things out. So those things are all changing in a very dynamic manner almost all the time through the year, okay? Now, with regard to climate, the intensity of the sun is one factor. The proportion of gases in the atmosphere, okay, like in other words, what percent of the atmosphere does CO2 and methane and nitrogen and oxygen make up? And what are the radiative properties of those gases? How well do they absorb incoming solar radiation? How well do they absorb outgoing infrared radiation from the Earth? All of those things come into play. El Nino and La Nina are things that last a long time and influence the temperature over a long period of time. Topography is not going to change. If it changes, then we're in real trouble. But obviously, it does have an effect on the climate in any one given area, how far you are above sea level. Volcanoes obviously are instantaneous, but their effect is very long term in the sense that their particles get up into the atmosphere and circle the globe, and so they end up actually causing global cooling over a period of a year or so, okay? Mount Pinatubo is a great example of that. The Earth's orbit around the sun. Right now it's elliptical. Is it going to become more elliptical, less elliptical? And then the Earth's tilt at 23.5 degrees. Might that change to 23 or 22.5 or 24? And all those things can have effects, but again, they occur over extremely long periods of time. Now, is there uncertainty? Of course there is, okay? Nobody is claiming that we can give you an exact forecast of what the climate's going to be like in 100 years. And if you hear anybody that claims that, then you know that they're out to lunch. You know they're not a real scientist, okay? There's a lot of people that pose as scientists out there, and they have very, how can I say this? Their voice is very convicting, and sometimes the loudest voice wins over the more intelligent, lighter voice, if you will. So be careful about that, because no responsible climate scientist has ever made that claim. Okay, the range in possibilities right now is anywhere from 2 degrees Fahrenheit to 9 degrees Fahrenheit by the end of the century. That's a big range. And if it's 2 degrees, we can probably adapt without too much problem. If it's 9, then that would truly be a catastrophe. So there's a retired professor from MIT that I got to meet several years ago when he came to speak in Raleigh, and Kerry Emanuel is his name. And he, I thought, put it best. He said it all comes down to risk assessment. He said if we can minimize the risk without harming people, why isn't that something we could all buy into? And without harming people, I'm going to be real honest and blunt with you here. If we cut into the multi-billion-dollar oil industry just a little bit, I don't really consider that harming anyone, okay? But the overall goal here is to figure out a way, instead of throwing rocks at each other, have a conversation and figure out a way that we can minimize the risk to the extent that we can without doing a lot of harm, okay? And I think it can be done. And don't listen to activists, okay? I don't know how many of you saw this a month or so ago, but a bunch of climate activists stormed the 18th green at one of the PGA golf tournaments and laid down on the green, and the police had to pull them off. I have no time for that kind of crap. Pardon my French. I really don't. I mean, that is giving good science a bad name, and I in no way support anything along those lines at all. So here are some closing thoughts, and it's advice, and it's my advice. You can throw all of this in the circular file if you want to. I'm just sharing with you the way I look at things. Political ideologies do not mix well with science. Science is about observations and measurements. Ideologies are about beliefs. I talked to a climate scientist down at Texas A&M one time, and she said, I do not believe in climate change. I accept it based on the evidence. And there is the key distinction, based on evidence. A belief system, you don't have to prove. If you go into a court of law and you say, I believe that this car is at fault, they'll laugh you out of the courtroom, okay? So science is about actual observations and measurements. Ideologies are about beliefs. Okay, when formalizing an opinion about anything, climate change or whatever, employ the scientific method. I used to give a talk, and the title was Scientific Method is Not Just for Scientists. You start with a hypothesis, which is what you think the truth is. And you can have as many of these as you want, about as many topics as you want. They're free and they're legal, okay? So go to town on it. But then step 2 is where it gets a little tricky. You test the hypothesis, and the best way to test a hypothesis is to do everything in your power to disprove it. Not approve it, disprove it, okay? And only upon failing to do that do you accept your hypothesis as your conclusion, okay? So this is what keeps the scientific community honest, is that they are always looking for faults in their arguments. And if they don't find it themselves, somebody else will find it for them, okay? And then you have to deal with the fact that, okay, my hypothesis wasn't correct. I've got to go back to square one and start over, okay? But right now, nobody has come up with any credible evidence to suggest that the warming that we have seen, or at least most of the warming we've seen, is being caused by anything but human activity, okay? So that hypothesis needs to continue to be tested, because it is possible that at some point we will find out that that's not the case. I don't think it's likely, but it's possible and cannot be ruled out. and resist the urge to engage in confirmation bias. We have an epidemic of this in this country on both sides of the aisle. And there have been many studies that have been done that indicate the more you hang out with people of like mind, the more extreme your position is going to become, okay? So we need to engage in civil, respectful conversations with people of differing views and accept the remotest of possibilities that we might learn something from that conversation. They might bring up something that we hadn't thought about, okay? I recently saw a video on YouTube, and for those of you that are young, these names aren't going to mean anything to you. But back in the 80s, a guy named Tip O'Neill was Speaker of the House of Representatives, and the president was Ronald Reagan. They could not have been more different politically, but they were great friends, and they oftentimes got together at the end of the day and maybe had a glass of wine together or had dinner together or whatever. We need more of that, okay? It's almost like we've become a two-cult system in our country, okay? It used to be two parties. They had differing views on how to get things done, but they talked and they got things accomplished because they did talk. And we need to do more of that. We really do. All right. That's my diatribe. Thanks you for putting up with it. That is bonus weather video number 3 for this week. Next one coming up Monday, and the daily weather update is already out, both short and long. And I hope you have a great Friday evening and an even better weekend. Take care, everybody.